Okay, so Chapter 7, Parent-Child Relationships and the Born Technique. So this chapter is emphasizing parent-child relationships, and you may be asking, okay, what does that really mean for, in particular, SolidWorks? Well, when you're making a SolidWorks part file, you're building a part with features, right? You make a base feature, then you put another feature on top of it, so on and so forth, till you end up with your end geometry. Well, as you create these features, each one of these features has a parent and child relationship starting to develop on top of it. And most of the time that just happens in the background. You don't have to worry about it too much. But when you're making changes, sometimes you can make a change that'll break one of those parent-child relationships, and that's where it kind of rears its ugly head at times, and SolidWorks gets mad at you, and you have to start thinking about, okay, what is referencing what in order to make the correct changes. So just to show that as an example right now, we'll go and make a very simple block with a hole in it. So I'm just hopping into a part template here, something we've done many times. And let's just create a nice square with a hole in the top right hand corner. Alright, so I'm going to make this in two different features. Let's say this is a 2" by 2" square. Let's call it 1/4 inch thick. Alright, there's our boss extrude 1. And on our boss extrude 1, let's use this as the sketch plane. Let's make a hole right around here. Let's make the hole, let's say, 1/4 inch in diameter. And then here's going to be the important part. Let's reference this left edge here and make it 1.75. And let's also reference the bottom edge here at 1.75 as well. Alright, so we're going through here. Made our feature very quickly here. And there actually is a parent-child relationship already developing here. And if I right-click here, you can go parent-child and actually expose that. And I'll bring this from another screen. And you can see here, this cut extrude 1 has a parent of this boss extrude because it references it, as well as the sketch 2 because that's the sketch driving the cut extrude 1. And the cut extrude 1 basically is a child of itself there. So that's all looking very nice. And you can see where, if you just hover over in this version of SolidWorks, you can see that little graphic hopping on the right-hand side of the tree is actually showing that relationship there, right? The cut extrude 1 has a relationship with the boss extrude 1 as it is its child. Even boss extrude 1 here, notice it also has some relationships as well because it's referencing the top plane and the origin, right? The top plane is what we sketched on, and we also made a reference to the origin there as well. And so that's another way SolidWorks is hinting at these parent-child relationships. So that's all good, fine. And you might say, okay, where would that possibly go wrong? Well, if I double-click on my boss extrude 1 here, and let's say I make this a 1" by 1" square, and at this point I'll rebuild, and look what happened here. I've got an error message popping up. I've got cut extrude 1 is all red. Part 1's red. Obviously SolidWorks is upset at this point. And this is one of those things that can happen as you make changes to features up higher in the tree. Sometimes you'll upset these parent-child relationships. And so you may ask me, what exactly is happening here? Well, if you remember, we specified this hole 1.75 by 1.75 from the origin, right, in the X and Z directions with respect to this coordinate system. But now that hole is trying to cut extrude, but it's not connecting through any material, right, because we've shrunk that cube down smaller. And so that's what's the problem here. Cut extrude expects to hit some material as it goes through that blind extrusion depth. It's not, and that's causing the error itself there. And so what you can do to fix it in this case goes back to the idea of design intent. I made that 1.7 by 1.75, so it was a 1/4 inch by 1/4 inch from that top right hand corner. If that was really the design intent, no matter what the size of that underlying square is, then I need to reference it differently. Instead of referencing it from the origin, I need to reference it from that top right corner. So let's make that quick fix, and we'll drag this guy down here. It's going to live somewhere in there. And let's say 1/4 inch and a 1/4 inch. Accept the sketch, and now we're happy again. And so now as I push this back out, make that a 2. I'll have that hole follow it there. And you can still run into issues if you've made this square very, very, very small, right, where you'd have that 1/4 inch become an issue. But it also allows you to do a lot more in terms of flexibility of the model at this point without running into those parent-child relationships there. Alright, so hopefully that all makes sense with respect to parent-child relationships. Got a few slides here just talking about it a little bit more. But also notice that these things can be very complex here. Here's a much more complex part file that I'm just showing the slide of. Notice the feature tree on the left hand side is so large that I have a scroll bar going up and down, and I just happen to pick one of the features near the middle of the tree structure here, expose those parent-child relationships, and you can see it has a number of parents, but it has even more children referencing it there. So you can imagine when you get to this size of model, this complexity of model itself, then you have to be somewhat more cognizant of these parent-child relationships as you go to make changes, because you've got a lot more things at play at this point. The other part of that chapter, we talked about parent-child relationships and the BORN technique. I'll use a few words here to talk about the BORN technique. BORN is an acronym for Base Orphan Reference Node. It's something in SOLIDWORKS you don't have to worry about too much. It's the basic idea that when you start into a part file, you start with kind of an orphan or reference node, and then everything else becomes children of that reference node. And for SOLIDWORKS, that reference node really is this origin and those 3 datum planes, the front, the top, and the right planes there for us. They're kind of the reference that we build everything on top of itself there. And so that's where I'm saying you don't have to worry about it too much in SOLIDWORKS. You already have that set in place, and then all the follow-on features become children of that reference node there. So that's where I don't spend too much time on it in SOLIDWORKS. Another thing that did happen, and hopefully you noticed it here, was this idea of rebuilding. And so when I was moving the square around a little bit and playing with the hole, at one point I had to hit Control Q on my keyboard to rebuild the model. And we can actually see this happen a little bit. So I come in here and let's make this 0.375. Alright, so what's happened there? I went in and I actually modified the diameter inside of that sketch dimension that drove the diameter of this hole. I changed it from 1/4 to 0.375, but notice the visual has not changed, right? The only thing that we saw change was this number right here, but the actual hole size on the screen did not change. And this is a case where SOLIDWORKS is basically needing to rebuild the geometry. And you can see a few hints with that. Most specifically, it's on the left-hand side here in the tree structure. You'll start to see these little stoplights show up at the sketch, the feature, also all the way up here at that root node, so to speak, at the part there. And that's basically saying SOLIDWORKS needs to rebuild. There's a couple different ways to rebuild. One way is to come right up here, and you can see there's a rebuild that's a Control B, and I can just click here and rebuild as well. And you can also, so I'll change it back to 1/4 and rebuild again. There's a Control Q rebuild. Control Q rebuild is a little bit harsher in terms of what it actually does, and so that's usually what I'll do on the keyboard. And so very rarely will I actually come up here to the top of the screen and hit the button itself, but you can very quickly just kind of get to muscle memory where you can hit Control Q when you see that a rebuild needs to happen at that point. And so hopefully that makes sense. You may have seen that a little bit on your own modeling when you're got a model most of the way done and you're kind of tweaking different things along the way. And if you ever see it not update after you tweak it, that necessarily needs a rebuild at that point in order to get the geometry correct on the screen. This idea of rebuilding and geometry changes kind of leads us into this idea of feature suppression. And so feature suppression is something that kind of talks about how to build a family of models inside of the same part file itself there. When you get down to feature suppression, you can say things like, well, I've got a hole here, but sometimes I want to see the hole, sometimes I don't want to see the hole, so I can suppress and unsuppress that hole itself there. Definitely increases flexibility as I'm showing here. And that hole, when I talk about feature suppression, it's not really deleted, but it's just hidden, if you will, at this point in time. And so an example of that, using the same model here, is with this hole here. If you click on the hole itself, the icon is right here, and it's the idea of suppress. So if I want to suppress that hole, I can click that icon there. Notice it still remains in the feature tree. It's kind of that grayed out appearance, but it's definitely not in the geometry itself. and then I can come over here and I can click the unsuppress button at this point and bring it back and forth. And you might be saying, okay, that's really nice, but really where that takes us into place is with configurations. And so first, a kind of an introductory slide before we get too far along. I've got a picture of some hex keys here, some Allen wrenches, and basically the question is, how many part files did it take to make this assembly? And you think, okay, part files, I've got 1, 2, 3, 4 different sizes of Allen wrenches. I've got a holder, so that could possibly be 5. If you didn't know anything about configurations, you'd say, hey, I'd have to make kind of the same geometry in 4 different files, right, for all the Allen keys. And then 1 is obviously the hex key by itself there. And so if you didn't know anything about configurations, that you'd do, and you'd make those 4 individual SOLIDWORKS part files and the 1 holder file. The problem is you have a lot of the same geometry happening in those hex keys, right? It's kind of a single kind of L-shaped sketch, and you've got a sweep that's actually creating the solid geometry itself there. And the idea with configurations is that those parts are going to be very, very similar, so let's make those in the same SLDPRT file and be able to share a lot of that information. And so I can actually show you the example of that here. So I pull it up in a different file. Here's the Allen wrenches, but now notice on the feature tree, you're usually sitting here on the Feature Manager Design Tree tab. Let's go to the Configuration Manager. And when you're working with parts, every time you create a part, you've actually been working with a default configuration. I'll actually come over to our cube that we've been playing with so far, and you can see on the Configurations tab, I've got this default configuration here. In this case, I've got, instead of 1 configuration, I've got 4 different configurations, and they all change the size of the hex key or Allen wrench in a little bit different fashion. So I can just double click on them to change the active configuration. So there's an 1/8 inch Allen wrench. I think that's 3/16, 0.1875. There's a 1/4. I believe it's 5/16 there. And you can see as I double click on these, the overall height of the Allen wrench is changing, as well as the diameter or associated size of that hexagon making up the cross section there. And so this is all done with configurations. And you can see this a little bit by coming into here, and if I look at individual dimensions, you would see them change themselves. So for instance, this guy right here, if I right click on it, I can say configure dimension, and notice this is where those values are stored. Inside of this, it's the Modify Configurations dialog box. D1 at profile, this is the sketch name is profile. D1 is the variable name for that dimension. And notice we're saying when it's the configuration of 0.3125, I want it to have this dimension. 1/4 is 1/4, 1/8 is 1/8, so on and so forth here. And that's how you assign different values to this sketch dimension based off the configuration itself there. And so hopefully that all makes sense. Hopefully you can kind of see the power of this as you would be making models that are kind of similar to each other. You could build those all inside the same SOLIDWORKS part file and be able to share a lot of the geometry itself there. Just to kind of tie this back again to configurations, let's go ahead and make a set of configurations here, one with the hole and one without the hole. And so I'm just going to right click on this configuration and call it with hole for this configuration name. And now let's say I want a different configuration where I suppress this hole to kind of tie back that idea of suppression again. So what I can do is right click on the root node and say add configuration. And I'll just call this no hole. And so now I've got the no hole variation and the with hole. And if I double click on each one at this point, they look exactly the same because I haven't really made them different in any way. And so what I can do with this no hole is then come to the cut extrude, and if I right click, I can see configure feature. Here I'm just getting a warning about some properties text file that I don't really need at this point. But now that I'm in the modify configurations dialog box again, I've got my 2 configurations names, with hole and no hole, and it's saying with cut extrude 1, I can suppress the hole in the no hole configuration. So I'll hit OK and apply it, and now as I double click and activate each one of these configurations, I can see the hole and not see the hole on their respective configurations themselves there. And also, just so you know, I've got a totally separate video because I'm going through these relatively quickly that'll dive a little bit more detail into some of these topics. Okay, last but not least, again, I like to throw some stuff in there that kind of expands beyond what you'll see in the textbook for MECT 121, gets you thinking a little bit more creatively, and especially helped for the FDM Derby project. This one I kind of thought of if somebody was trying to make like an airfoil type design there. Maybe you could go online and find some information to describe the curves of airfoils, and then you wanted to bring that into SolidWorks, and so you could use like a sketch picture type of scenario there, where you traced it with a spline in space, but also if you had the actual data of the curves itself, you can actually use that data and bring it into SolidWorks to derive geometry. And we actually do this in a later on class. When I was teaching kinematics, we'd actually make these plate cams, and our textbooks would allow you to develop the perimeters of these cams, or the contours, the outer contours of them, through a set of equations that we would work through. And that would allow us to then be able to build the cam to achieve some described motion that we would have beforehand. And the challenge would be I would do all this calculations in Excel, and we would need to bring those coordinates into SolidWorks. And I just have a few slides here to talk about that process. One of the things you would do is in some way calculate these coordinates, and so we used Excel here. So I've got a total tab over here which has all the calculations, but then after I get to the point where I need to copy them out into SolidWorks, I would just create a new worksheet, and you can see the worksheet's very, very simple, right? I just have columns of data in columns A, B, and C, and think of columns A, B, and C as the X, Y, and Z coordinates of the individual points. Now, SolidWorks can't accept an XLSX file, it can't accept a Excel workbook, but from an Excel workbook you can save this worksheet out as something very simple, like a text tab delimited file, where it's just value tab, value tab, value in this case. And so that's what we did. We get to a simple text file, and then what you can do is actually bring it in through SolidWorks. And so you do that through curves. And so just kind of going back to where I'm at here in SolidWorks, you have curves here, and there's curves through XYZ points. And so at this point you could actually browse for that text file. It would then load it into the SolidWorks tool, and then you can hit OK to actually generate this curve. That curve then can be used to derive additional geometry, in this case the plate cams. And so that's kind of what the preview would look like after you've loaded the points. You can see SolidWorks has successfully loaded the points from that text tab file into the tool itself. It's showing you a preview of the curve, and then you could of course accept it at that point. And just kind of getting a little bit on the tangent here of what you would see in kind of the kinematic sense, this would be the type of inputs you would have to this problem, where you'd have a follower. Those had some prescribed motion you were trying to achieve, an angular velocity at which you wanted to spin the cam, some information about the type of the cam, and you would basically use it to build these cam systems. And just to show an example of what this looks like on screen, oops, let's try a different media player here. One moment. There we go. You would see something that looks about like this afterwards. Now, of course, this doesn't happen right after you do the boss extrude, right? But you can, inside of SolidWorks, do these type of kinematic relationships there, and that's kind of a follow-on activity, right? Inside of MECT 121, we're spending a lot of time doing work associated with part modeling, and eventually we'll get to assembly modeling and making drawings. But part of the design process, remember, is not just making these models, but then also trying to validate them in some way, right? Making sure that what we think is going to happen inside of the assembly or inside of the mechanism is truly going to happen in reality after we make it. And kind of the in-between stage there when you actually are testing it is when you test it in the software. And so this is a kinematic simulation where we could actually build the mechanism itself, apply a rotary motor to the cam, and then be able to make the follower do its certain motion there. And we'd actually go as far in kinematics as being able to say, okay, I want to make this kind of video inside of SolidWorks, but then I want to pull data off of the video itself and see if we've achieved the type of follower displacement that we were seeking at the beginning. And that's what this graph is showing. The fact that that blue line and that black dashed line is matching up, shows that those two sources, the theory, and which is basically what I wanted to achieve, and the SolidWorks is basically saying, hey, this is what you're going to get, are matching up quite nicely. And so I think that wraps it up for the video for the most part here. We've been going for roughly 20 minutes, so I like to keep these fairly short, and the idea is just to introduce you to the concepts of the chapter itself. Again, Chapter 7 is mainly focusing on this parent-child relationship, where you've got features that reference other features in some ways, either sketch references or possibly an extrusion where you're saying up to next, something along those lines. We also talked a little bit about a few other features, talked about rebuilds, feature suppression, and how that kind of leads us into this idea of configurations as well. So hopefully that gives you at least a high-level overview of these concepts and gives you a starting place to go from as you work through this week's material.